Are we live? Looks like.
I don't think so. Yeah, we're live. We're live.
Okay, cool. Hi, everyone.
Hi, everybody. We are here. I don't know. Let's. Hi. It seems that people start to gather around. Now let's go. I'm now realizing that we are a bit of a clones. Now that I see this view of each other next to one. Hi, I'm Ivan. I'm a product manager at TinyBird. I'm the product manager of the team that has developed the API that we are going to show just today.
And I'm Gonzalo from the data engineering team. And today we are going to be the host of this session about the duplication and the scheduled copy API.
Right. Now we work TinyBird. We are going to show TinyBird, but the general case and the general problem it's, let's say, universal to analytical databases. And in case you are not familiar with TinyBird, we are a serverless database for developers. So you can throw data at us and build fast APIs faster using the skills you already have using APIs, SQL. And we are not only database per se, but we put on top of that a great developer experience. That's what we think, and you will see also today. And you can watch all the videos in this channel.
And everything that we will do in the session, of course, you'll have the recording afterwards, but you will also have a GitHub repo that we will share. And if you have any doubt, just post it in the comments here, ping us on Slack or whatever you need. Okay, happy to help.
Okay, so what we'll cover today. This session is named. It's called Deduplicating OLAP with scheduled data snapshots. So first, let us talk a bit about why the duplication matters in analytical databases, and we'll solve a couple of problems of typical scenarios that you find. One is schema migrations that are not per se related to the duplication, but it's one good use case to introduce our new API, our new copy API, and then we'll deal with the duplication using snapshots, using this new API, but in a scheduled way. And we'll solve it using a common pattern that it's called Lambda architecture. So yeah, I think you'll find it very interesting.
Yeah, hope so.
So why the duplication matters? I mean, first of all, if you are here because you are interested in how to deduplicate in ClickHouse. ClickHouse is the database that we use in TinyBird. We have a in detail guide on our guides, tinybird.co/guides, around the duplication strategy. This is one of our most visited guide, so it's a hot topic. And now to give you a summary on that article, and why this matters. Analytical databases are optimized for fast ingestion, are optimized for bulk processing instead of going row by row. And for doing that, you need to take some trade-offs. You have some trade-offs. One of them is that they lack unique constraints. So in order to, because of that, the general pattern, the general flow that you use is, let's throw every data at the database. Let's ingest all data first, and then we'll deal with duplicates later when analyzing the data. And there are typically two scenarios when you end up with duplicated data. One of them is absurds. As we don't have that those unique constraints, you send everything. You send when an entity is new, every update to that entity, and then you have to get like the most recent one, for instance. And another scenario when you end up with duplicated data is when you have constant ingestion with lots of rows inserted at different times with the same primary key. It's similar to the previous one. This is typically seen in change data capture scenarios when you send from a transactional database to an analytical database on updates on your items, on your events.
Yeah, it's the typical trade-off between OLTP and OLAP. In OLAP, you have this query speed and the fast ingestion. So it is always better to send everything to the database and then deal with the duplication later. And yeah, if you visit our guide that is here, highly recommended if you're working with ClickHouse or you have doubts in Tinybear. The four strategies we recommend are dealing with the duplication first at query time. That is when you build your query, you make sure to get only one row, usually the latest row by timestamp that you want to retrieve. The second and 3 points are kind of similar. Using a replacing merge tree or materialized views, it will tell ClickHouse to use these kind of engines to manage the duplication, but please note that you will also have to deduplicate at query time, because this deduplication, the replacing merge tree, the merging of the ClickHouse parts is an async process, and you cannot rely that it will be already deduplicated when you query. So 2 and 3, you need to combine them with at query time as well. Okay. And lastly, snapshots is another way of dealing with these use cases that will also have some other benefits, like having a historical view of all the changes. And this is what we are going to see in this coding session.
Okay, and in the coding session, we're going to use this new API that we call Schedule Copy API. We announced it 2 weeks ago. It's in beta, and if you are interested in using it, reach out to us in our Slack community channel or via mail. And you have there's already the documentation there's the API reference, and there you have a lot of information of the current state of the API, how can you use it, and everything.
Yeah,
here it is.
The section.
Yeah.
Okay.
Okay, and we are going to use a workspace with this scenario for showcasing the two problems that we are going to solve. And it's a made-up example, a simple example for you to understand what's happening. We are sending flight reservations to a data source, all flight reservations, and you have an example of the schema down there. You have the timestamp of the update to that reservation, the identifier of that reservation, the flight number, and some information that it's attached. So users can modify, okay, I want now to change my meal choice, I want to put some extra bags, However, you can see the last two records are referred to the same reservation. And that's it. And first of all, we are going to deduplicate in the query. That was the first, it's the most simple one, and the first one to be mentioned in our guide. So let's go. Let's show the workspace.
Yeah, here we have the workspace, and here we have this flight reservation data source where we have been ingesting some data, and as you can see, well, the same schema Ivan mentioned before. And now, if we are part of the flight crew and we want to prepare, like know how many passengers, how many kind of menus we need to prepare, we should do a query like this one. Okay, where in the first node of the pipe, well, for those of you that are new to Tinybear, this here is a pipe that is like a Jupyter notebook where you can type SQL queries, and then in just one click, converting that into an API endpoint that you can hit, and parameters and these kind of things. Okay. So first, in this first node that is called dedup, we are following one of the strategies of the guide, that is deduplicating at query time using the limit one by the field we want to duplicate, and we are getting the newest version of that transaction ID. Okay, here in the guide, the deduplicating on query time, we can see the limit by, but also the argmax or the hub query. Okay, this one is a bit verbose, so this is why we chose it. And in the second node, you can query the previous node. Here we are running a query to the duplicate data, and just calculating the number of passengers, the extra bags, priority boarding, and each kind of meals. Okay.
Okay, just to insist or to highlight, the first node, what we are doing is deduplicating using this strategy of using the limit one by the primary key of the events that you want to deduplicate. And then the real query that we are interested in is the second one, that is, compiling those events on a flight number to get information out of that flight number. And now we are sure that this information is reliable because it has the most recent data for all transactions. Okay,
yeah.
And this works well now because we've been ingesting data in this data source from today, so it's not a big one, and you can run it. It goes fast, but it compounds. In a year from now, and that query would be like impossible to run. So you need to find strategies to make that more performant.
Yeah. For instance, here for running this query of a particular flight, we are scanning 31 megabytes, and if we look at the data source and at the schema, we can see that we always filter by flight number, and flight number is in the sorting key. So it should make much more sense to have it in the sorting key, and this is what we are going to do right now.
So
okay.
Yeah, in Tinybear, we always tell our customers, we encourage always to think backwards, like to think first on what questions do you want to do to your data, and then build from that point backwards. Like think first in the query, and then that query will determine what you need to do in terms of a schema, of sorting keys, everything. a lot of times you don't have that information beforehand, and you find out as the project grows. In this case, it's very clear. The query that we want to do most of the times. The most popular query that we want to use is using a filter that it's not in the sorting key, so this is not efficient at all. So this slide us into our first use case of the copy API. That is schema migrations. And what we are going to do is let's create another data source with a better and more suited sorting key, and then use an copy operation to copy the data from the original one to the new one. That will be more performant.
Yeah. So to do that, let me come here and show you. Well, first, let me update my token and host. Okay.
First, we need to create the data source, right?
Yeah. This is the data source that we already have, and let's create a copy of this one with the correct sorting key. Let's rename it to flight reservations _ SK for sorting key. And as we said, in the first element of the sorting key will be flight number. And the second will be a timestamp, okay? And we can remove all these other fields that we don't need, okay?
So now it does this seamless plug. In Tenable, as you are going to see, you can work in several ways. One of them is using the user interface, and the other one is to use the CLI. You can get your data project, all the things that you show in that workspace. You can work with them in our own text files, and then you can have it in GitHub, whatever, and work with Tenable through the command line. This is a very powerful feature of our platform.
Yeah. So yeah, let's do a TV push of the data source we just defined here. And flight reservation SK created. Let's double check that it is here. Okay, flight reservation SK is as we define, and the sorting key in the schema is better for our use case. Okay. So now, going back to this, we should create a copy pipe that will move the data from the data source with the wrong sorting key to the data source with the good one. Okay. So coming here to the README. Yeah, we've done this. Okay, yeah, let's create a new pipe. Let's create a new pipe that will get flight reservation. So let's start from flight reservations. We call it change SK to the pipe, and the node is called copy _ node. Okay. And you can see here that is a regular pipe. It's not a matrix view, it's not an API endpoint, and it's not yet a copy pipe. So we need to transform it into a copy pipe. How do we do this? We have already shared the documentation, but as you can see here, it's as easy as doing a post to the pipes API. You specify the name of the pipe and the node and to convert into a copy one, and then add the destination data source where you want to send the data, okay, the result of that query. So let me run it here. And looks like it's already converted into a copy pipe. yeah, the icon changed, so we are fine with that copy pipe.
So now you have three different three kind of pipes. A pipe that serves as an API. If you publish the pipe as an API endpoint, you can call it for external sites for your applications. You can have pipes that materialize data in using a materialized view, and now you have pipes that are used for copy operations. So yeah, what Gonzalo just did is to, okay, let's set up this pipe as a copy one. And now we have to run, we didn't set up any schedule at all because for this use case it's not, I mean, it doesn't fit. So now what we are going to do is to run an on-demand copy. Let's say, okay, get the results of this pipe and copy on the destination.
Yeah, and for that is just calling the pipes API with the name of the pipe and /copy. And here we have the response, and in flight reservation SK, if I refresh, now we have all the data that we had in the previous one. Okay.
And now let's check that it works better now.
Yeah, so let's double check here. 32 megs to have this response. If we duplicate the query and rename that pipe from SK, instead of going to flight reservations, we go to flight reservations SK. We perform this query and it's 1.33 megs, which is...
What was the other one? 35 megabytes?
The other one, status query, 32.2, and this one, 1.33.
It's almost 30x improvement just by choosing the right sorting key. So perhaps it doesn't have much to do with the duplication if you are here for that, but choosing the right sorting keys is key, no pun intended, to have very performant queries, to process less data. Yeah, everything shines more.
And now let's go for the
duplication case. Now you've seen that we are sending all events related to flight reservations, and yeah, we get these duplicated entries. Let's say these upserts of flight reservations. So what we are going to do is to use what it's called the so-called Lambda architecture, that it's combining process data plus the real-time data. Depending on where you read it, you would say you have a batch layer and a stream layer. What we are going to do is to calculate to duplicate only the last minute events, the events that happen in the last minute, to duplicate that and combine it with the latest snapshot that we have. And for the sake of this demo and to watch things going, we are going to do this snapshot every minute. So you end up with a complete picture of your reservations, the duplicated reservations every minute. So, and we'll use those snapshots to calculate, okay, we have the duplicated entries at, I don't know, 1730, and then I need only to duplicate the last minute, and that's it. Combining like process data with the real-time one, so you have to process way less data.
Yeah. Okay, so we had the pipe already prepared here because otherwise it will be too long to write all this SQL here. But yeah, what we are doing in each pipe, we have 3 nodes. In the first one, we are taking we are deduplicating the entries that happened from the last snapshot to now minus 1 minute to avoid race conditions and these kind of things, okay? And we use the limit one by transaction ID as we did in the query, okay? So we deduplicate and we just get the latest update for each transaction ID, okay? In the second one, we still don't have any rows in flight snapshots. We haven't started yet, but what we are doing here is all the rows that were in the previous snapshot and have not been updated in this time frame between the previous snapshot and the new one. We want to maintain them. We want to keep the full picture of the data source of the reservation. So we get them in this node. And lastly, we combine both nodes with a union all. And also, what we are doing here is in order to identify each snapshot, we are adding here the snapshot ID with the timestamp that will represent.
Okay, just to iterate. First node deduplicates the last minute events. In the second node, we get the records from the latest snapshot that have not been updated. We are doing that with a simple transaction ID, not in the set of transactions that has been updated, and then we combine it together. And in this case, the schema is the same one as the landing data source, where we gather all events, and we add this column with the identifier as the snapshot ID, so we can identify one snapshot from the next one.
Yeah. And yeah, as you can see, it's a regular pipe, so we need to convert it into a scheduled one. Okay. Same things as before. The pipe and the name of the node, destination data source. In this way, flight snapshots, and what we are doing here also is adding the cron expression that will tell us Tinyver how often this query needs to be executed. Okay.
Yeah, and flight snapshots we created beforehand, to speed up this demo, but the mechanism is the same one that you saw in the sorting key iteration. Is creating this that data source file, putting it to Tinybird, and that's it. The schema of the data source has to match the schema that from the query of the query. I mean, if not, we have a mismatch, and that's it.
Yeah. So yeah, let's create this as a schedule copy pipe. Refresh, and okay, already as query. As you can see here, still no rows, but in a minute we will start seeing this data source being populated and with all the data. Okay. So
yeah, in this case, we called the API with a cron expression, so we don't have to run any on-demand copies. Tinybird makes that for us in whatever schedule we set up. And in any case, this repo, the link is there on the comments, so it's public. If you need to take a deep look, a look in depth on the queries because you want to study a bit more, it's there, so you can download the data project and take a look on the queries. So the first copy already run. Now if we go back to the duplicate query, you can see that we already have like a prep snapshot. So now every minute we'll get like a newer snapshot, and we don't have to do anything. Everything is done by TinyBear, and yeah, and it leaves. I mean, you don't have to do that.
Yeah. Let me check if we have more than one. No, not yet. Okay. So yeah, what we did before was querying the flight reservations with a proper or an incorrect sorting key and deduplicating always at query time. And what this feature enables us is creating snapshots and then just querying the latest status of the reservations. Okay, so let's create a new pipe here, a new status query. Duplicate status query.
So what we are doing now is, instead of querying the original data source and duplicating in the query, we are going to query the snapshot data source.
So snapshots. We don't need to duplicate anymore. We only need to tell that we want the snapshot ID as equals select max snapshot ID from flight snapshots.
So we get the latest snapshot. Okay.
So yeah, this is the latest snapshot. And then in the result, we query from the previous node that is called latest snapshot. And you can see here that we are processing like 400 kilobytes. That is way less than in the previous two examples that were like 30 megs and 1.3 megs.
Okay. No, so it looks like amazing, but if you are, perhaps you are thinking, I think it doesn't add up. It doesn't add up because we are querying a snapshot, but we are losing like the real-time data that happened between the snapshot and now. So what we are to do now is to apply the same Lambda architecture that we did in the duplicate pipe to this query that consoles the snapshot. So what we are going to do is, let's get the latest snapshot and combine it with the most recent data that we have in reservation. So we have best of both worlds, real time and persist data.
Yeah, as Ivan said, here we are losing the data that changed in the last minute. So yeah, let's do a proper a query with the freshest data. That is our goal here at TinyBear, and let's duplicate this pipe. Let's call this Lambda. Well, not sure if it should be Lambda or Kappa, because, well, anyway, it's a way to combine pre-processed data and real-time data, but we do it here all in the same tool and just using SQL. Okay, so latest snapshot here. Then we need to, let me copy it from here because my mind is, I don't have that many, yeah. Then status query Lambda. Latest snapshot is here. We query flight reservation and only for the timestamp higher than the latest snapshot. So select max snapshot ID from flight snapshots. Okay, and this is the RT dedup. Okay. Flight number.
No, we don't have any data for that particular flight number in the last minute.
Okay.
It's okay.
Okay. Any others that we know? Well, anyway. Yeah, anyway.
Try with IB 3805. Let's see if it works.
Yeah, we have some data here.
That's a flight to Ibiza. If in case you are thinking on planning your next vacation. Okay, so we have data in both.
Yeah. Let me reorder this here, move it a bit upwards. So we have the latest snapshot from the snapshots, the duplication from the flight reservation from the landing one. Then we need to combine them. So let's do a select start from a latest snapshot, union all, and select all from RT dedup. Okay, one thing here, because in latest snapshot, no, it's okay. We don't have, yeah, it's okay. We have the same columns, I guess. Cool. So
the thing that we need to do is to not if a transaction ID we not how can I say it? We don't want to have duplicated entries between those both nodes. So from the snapshot we need to discard any transaction ID happening in real time, as we did in the deduplicate pipe.
Oh, true. So okay, and transaction ID not in select distinct. Well, it's okay to select transaction ID because we are doing a duplication by that from RT dedup. Okay, and then for the sake of the ordering, let's order it this way. Okay, cool. RT dedup, the latest status, then latest snapshot, removing the rows that have changed in that minute, Lambda to do a union all of the two, and result to run the query. Okay.
So this is a made-up example. That's why you end up with 358 passengers. But I mean, the same flight number can happen in Thursday, Friday, Saturday. So
yeah,
in case you are wondering,
it's one of the big.
There are a lot of people that want to go to Ibiza in summer, so that's why.
Yeah, and yeah, as you can see here, 600 case compared with the snapshot that was like half of that. But here we are getting all the information in real time. Okay.
And if you compare to the first one, that was only the duplicating in the query.
Yeah.
And with a wrong sorting key, now we have 33 megabytes versus 600, right? So
yeah.
it's
let's create it as API endpoint, and yeah, here you have it.
And one of this is how you would apply snapshots in a Lambda architecture to query to deduplicate. Okay, this is a common pattern. You can apply it in Container very easily, or you can make your life harder using other tools. And another benefit that you have getting the snapshots is that you have an historical view of how data was performing, so you can then use it for historical reports comparison. So for instance, if you go to time series, we can this is a feature that we have to visualize data sources. So create one.
Yeah, let's go for it. Right,
So
snapshots. Yeah, and here you choose one column to be the x-axis. It needs to be a date time, so snapshot ID. Last hour, grouped by 1 minute, I guess.
Okay,
and
yeah. So if, for instance, you can see if you select the last, you can select the last 20 minutes or something.
Yeah. 30 is okay.
Okay, it's okay. Yeah, so we have started to make these snapshots during the demo, so that's why you have this starting point, and you can then see the evolution of particular flights or a particular flight in concrete, and then you can use it to compare. If you run this snapshot for a long time, you can compare what happened in between seasons or what has happened during this campaign or whatever. I mean, it depends a lot on your use case, but having the snapshots, it's also great to do this kind of stuff. Okay, so that's mostly it. Just to wrap up,
let's add the things we've done to the repo, or not?
Okay, yeah, go ahead.
Very, very quickly, let's create a new branch, git checkout -b LCS. And
LCS stands for live coding session.
Yeah, sorry, I have an issue with acronyms and these kind of things.
That's one of my pet peeves. I don't understand acronyms.
So okay, let's download all the things we've created.
You can you show the div one, like the changes that happened during the session in the Git?
Okay, this is not tested.
No, I was not saying this.
Oh, sorry.
I was saying in Visual Studio Code, you have this tab where you can see what happened.
Okay. But yeah, you can use tvdiff. That is a thing that we are working on that tells you what were you trying to... Sorry, Ivan.
Now go to the tab of Git in Visual Studio Code where you have these 10 changes.
Okay.
So you can see all the work that we've done iterating this data project during this session. You can see there.
Yeah, but I was with the tvdiff. Also, you can compare what you have in your local repo with what you have in the server, because as I have done, some pipes have been created in the UI and are not present in my repo. Here the tvdiff tells me that this is the for example, change SK only exists in remote, status query from SK only exists in remote. And the tokens have different names, this kind of thing. So let me echo. This is called .diff, right? Diff tmp into.
I mean, this is a bit of showing off.
Yeah.
Because this is not about the deduplication.
Yeah, it's not about the...
Yeah, we are improvising a bit here. So bear with us.
So, but if you have any question regarding the duplication, please post it in the...
Yes, and I want to say that next steps, because the schedule copy API, it's a beta feature. So in case you're interested and it fits your use case or you want to try it out, let us know. We have a community Slack that it's open to everybody. You can sign up for a free account, for a free developer account to test anywhere, not only for this, for anything. We have start kits to help you to get up and running. And the next steps on the schedule copy API, it's to integrate it in the end user interface and CLI. Right now, it's only an API, but we are working on getting the delightful experience of Tinybird also for this feature, both in user interface and the CLI, the command line interface. And that's it. What are you doing, Gonzalo?
Yeah, I'm just downloading everything until TBDIF is kind of clear. So I think we are fine. It's just tokens. So yeah, let's add these things and commit live coding session. Commit, git push, and we're done. Okay, and we'll ask you for approval to the pull request.
Okay, go to GitHub.
Okay, coming here to GitHub, compare and pull request, live coding session, reviewers, and
I'm going to approve it. No problem.
okay.
You don't have to bribe me or anything.
You have to, but I expect some comments and these kind of things.
Okay. But as you can see, you can also work like in the typical workflow that you have as a developer with data projects in Tinybird. So everything's good. And I'll take a look. I'll take a look and approve the request, so you can get the updated. Well, it's better for you if you want to try or you want to test the data project to download the main version and then take a look on the merge request for the changes that we made here instead of merging it. In any case, you would need a generator for the data that you don't have. But it's very interesting for you to follow in detail the steps that we took during the session, see the Lambda architecture, the way that you can compound the nodes in the pipes to deduplicate. Again, if you have any question, reach out to us. And I don't think we have any question or anything.
Let's double check.
This is the first time I use this stream thing.
Yeah. No questions, I guess. So we explain ourselves very clearly. That's why.
Yeah.
That's why no one asked. And and okay, see you in the next live coding sessions. And as said, if you have any doubt or anything, just ping us.
Thank you, Gonzalo.
Thank you, Ivan. See you all. Bye.
Bye.